if log m to base a is equals to n, show that log m to base 1 over a is equals to negative n. Hence, find log of 27 root 3 to base 1 over 9. Hence, find that. So this is the part A of the question, and this is the part B. Part A says, if log a m to base a is equivalent to n, show that the log of m to the base 1 over a, that is inverse of this base, is the negative of this result. We are given, we start proving, given that log m to base a is equals to n. Okay, this implies that a to power n is equivalent to m. That's what it implies. Alright? No. At once, let's start something. Let's show this is true. How do we go about it? Now here is it. Having this a to power n is equivalent to m. Let's take the reciprocal of the both sides. Say, take the inverse, the multiplicative inverse. That is the reciprocal, multiplicative inverse. That is the reciprocal of both sides. Of both sides. So doing that, we would have 1 over a to power n equal to 1 over m. Okay? Here, we're going to have that, are you confused about this? The reciprocal of a to power n is 1 over a to power n. It is still the same thing as 1 over a to power n, because 1 raised to power n, a raised to power n. 1 raised to power n equals to 1 over. So it's the same thing as this. Don't be confused. It's the same thing as that. So we go on. I'll spoil my question. All right. Excuse me. Okay. Now, from here, let's do something else. Let's try something else. Let's take the negative powers of both sides. The negative powers of both sides. Take negative powers. No, we're trying to get this from here of both sides. So taking the negative powers of both sides, we have 1 over a negative power n is equals to 1 over m negative power. The power here was power 1. So taking the negative power of that. Now simply, let's go further. So solving this. Now observe that the right hand side is equal to m. 1 over m raised to power negative 1 is equal to, this power negative 1 means 1 over m, which means m goes up, this comes down. So that will be m over 1. That is m. So the right hand side, the 1 over m raised to power negative 1 is m. Because of that, we will have here, because of that we will have that 1 over a power negative n is equal to m. This implies that if you take the log of both sides, okay, let's say take log of both sides. Take the log of both sides, would have log 1 over a raised to power negative n. Let's say we take the log of base y. Let's say we take the log of base y to both sides, which is equivalent to log to base y of m. This means negative n log of 1 over a to base y is equivalent to log of m to base y. Go down, will soon be true. Now, how do we do this? We continue solving further, solving that. Let's make n the subject of formula. Sorry, negative n. So negative n will be equal to, that means we divide both sides by what? By this. We divide both sides by that. So that will be negative n equals to log of m to base y over log of 1 over a to base y. Here we can change base. We can do change of base here. So applying the change of base there, we have log of m to base 1 over a, which shows that this implies that log m to base 1 over a is equals to negative n. That's not wonderful. That's all you have to prove. You've shown that. First question says shows that this is true. So we've shown that is true. The part B of the question, let me write this on the side so that I can get the part B in the other side. You're done with the part A. At once you have okay, log m to base y over log 1 over a to base y is equals to negative n, which means, this implies that log m to base 1 over a is equals to negative n. Proven or shown. We have to show. So that's shown. Now part B says find the log 27 root 3 to base 1 over 9. Hence, find that. Let's bring in something. Watch how we're going to solve this. Let x be equal to log 27 root 3 to base 9. Let x be equal to that. So that we have here that 9 raised to power x will be equal to what? 27 root 3. Alright? Let's simplify. This implies n raised to the power of x is equals to 9 times 3 root 3. So dividing both sides by 9, you will have 9x divided by 9 is equal to 3 root 3. Is that okay? So we solve for that. This means 9x negative 1 equals to 3 times 3 to the power of 1 over 2. Now this means 9, let's change it to 3. This means 3 to the second power of the power is equals to 3 times 3 raised to the power 1 plus 1 over 2. Alright, so we do a cancellation here, since the bases are the same, due to this equality sign, since the bases are the same, then the power should also be the same. So in this case, we equate the powers. We say 2x minus 1 is equals to 1 plus 1 over 2. So 2x negative 2 is equivalent to 1 plus half is 1 and a half, that's 3 over 2. So we have 2x is equivalent to 3 over 2 plus 2, that's 7 over 2. Therefore, x is equivalent to what? Therefore, x is equivalent to what? Therefore, x is equivalent to 7 over 4. That's the value of x. Recall that x was equivalent to log 27 root 3 to base 9. So that means 7 over 4 is equivalent to log 27 root 3 to base 9. Then what will be, therefore, log 27 root 3 to base 1 over 9 will be equivalent to negative 7 over 4. This is the result, negative 7 over 4. How do we know that log of 27 root 3 to base 1 over